We have confirmed parachute deployment.
Tumbling back to Earth, the secrets of the universe.
So we have touchdown.
Namely, a few hundred grams of dust from an asteroid called Bennu, which may, scientists believe, give us the first clue about the formation of the planets.
Bennu, we think, formed right at the beginning of the solar system 4.5 billion years ago, and it's basically been deep frozen since that time. So it's going to tell us what was around before the planets were around.
Earlier today, the spacecraft jettisoned its vital cargo, sending it screaming into the Earth's atmosphere at more than 27,000 miles an hour, where it landed gently in the Utah desert at 8 minutes to 4 UK time.
Visual on the SRC.
Potentially, missions like this may help us prevent horrendous asteroid strike on the Earth in the future.
It's the culmination of a 7-year, 4 billion mile journey to Bennu.
Liftoff of Osiris Rex.
A 78 million ton chunk of rock, dubbed the most dangerous in the solar system. The probe launched in September 2016, aiming to gather just 250 grams of dust from the surface of Bennu. 4 years later, in October 2020, after 2 years orbiting the asteroid and mapping its surface, it made the approach to a crater in Bennu's northern hemisphere, where an arm plunged into the asteroid's loose surface and gathered the debris. In May 2021, it said goodbye to the asteroid and headed off on the 1.2 billion mile journey back to Earth. The end of an epic mission, but the start of the next one. Well, I'm joined now by the legendary Queen guitarist and astrophysicist Sir Brian May. He helped plan the mission and has co-authored a book about the asteroid and the Osiris-Rex project with its leader, Dante Lauretta. Sir Brian May, it's quite an extraordinary story, billions of miles of travel. How big a moment is it for you that this dust has now arrived back on Earth?
I got pretty emotional watching it. I was wishing I was in Utah, but we're here in glorious Wimbledon rehearsing for a big Queen tour in the States, so I couldn't actually get to Utah. But yes, I was very, very moved. You know, this has been a long journey. Of course, even longer for Dante Lauretta, who's the boss of the whole project, the chief. But yeah, I mean, there's a lot of me in there, and you know, you very kindly said I played a crucial role. I played a small role, but the role was to try and make sure that the spacecraft was safe as it collected that sample, because if it had fallen into the rubble, nothing would have got back to Earth, which would have been a bit of a tragedy after spending billions of dollars on the whole project.
Well, I want to come back to your role in this in just a second, but I mean, what do you hope, with your astrophysics hat on rather than your guitar hat on, of course, what do you hope that we can learn from this dust that's been gathered?
Well, the greatest thing would be if we could find the seeds of life itself. That's always the dream. And there is hope of that because, of course, we get stones through the atmosphere every day coming from outer space. They're called meteorites, but they're all burned up by the time they get to the surface of the Earth and they get contaminated by the air. These samples are pristine, and some of them are incredibly delicate. They're sort of very friable, like a sort of crunchy bar or something, you know, so they would never get through the Earth's surface. The fact that this magical box has managed to get them back to Earth intact is very significant. We can examine them and this is something we've never actually seen before on the Earth's surface. So well, it's possible we could find...
Sorry, go on. It's possible we could find...
Well, it's possible we could find, I mean, the ultimate dream, I suppose, would be to find RNA, you know, the smallest building blocks of life, but there are many stages in between if we found which could indicate that life did in fact come from outer space. I mean, it used to sound like a bit of an extravagant claim when Fred Hoyle proposed this thing. He called it panspermia. Maybe life came from outer space, but now people are taking it much more seriously because actually asteroids have brought all the air and water that we see around us plus all of the elements that we use, the gold and silver. So it's possible that they brought life as well.
And your role in it, you said, you know, to make sure that the dust could be collected safely. It was, as I understand it, it was producing stereo images that were then beamed back to Earth to work out where exactly the dust could be gathered from. Is that right?
Yeah, stereoscopic imaging has been my passion for a long time because it gives you such an incredible feeling of being there. It gives you an intuitive idea of what the terrain's like. So this all began for me when I sent some of our stereo images that we'd made from the data that had come back already from the spacecraft as it was orbiting Bennu. So I put some of these stereos together with my wonderful collaborator, Claudia Mansoni. We sent them to Dante, who's the chief scientific officer of the project, if you like, and he was amazed because they were looking for a safe place to land, and it was much more difficult than they'd anticipated. They thought they were going to land on a solid body like the moon, and they could just bump down, take the sample and go away. What in fact they found was a rubble pile, which is not a term of abuse, it's an actual scientific designation now. It's a pile of rubble very loosely held together by gravity. So there was a real risk that the spacecraft may land and topple over. We had to find a safe spot. So stereoscopic imaging suddenly gave them a nice intuitive view of the possible landing spots.
And just briefly, I mean, you've described in this book you've co-authored about the mission, asteroids are the prime bringers of life. But of course, there it is. But of course, Bennu is the most dangerous asteroid because it could, in theory, impact with Earth sometime in the next century, couldn't it? Wiping us all out.
That's right. Yeah, it's the irony, isn't it? Asteroids being the bringer of life and also possibly the extinguisher of life. Yeah, it probably wouldn't extinguish life. It's not quite big enough to do that, but it would make a terrible mess if it collided with Earth. So obviously the hope is that we will be able to track its future path much more accurately thanks to this visit and avoid such a thing happening. It's actually not that far in the future. It's only a couple of 100 years' time that it will come very, very close to the Earth. Yeah. And after that, nobody can predict it because it's a many-body problem which can't be solved. So it may impact us. And you know, deflecting it is not as easy as it might seem.
Well, let's hope it's not another one bites the dust then. So Brian May, thank you very much for joining us. I'll let you get back to your rehearsals.